your test is going to cover 6.3, 6.5, and 6.6. And then 12.1, 12.2, and 12.3.
6, 7, okay.
Oh, it should be 6.6. Thank you. 6.6. Okay, which was all the function stuff. And started with piecewise functions, got into composite functions, combining functions, all that stuff. And then inverse of functions is how we end chapter 6. And then 12.1, the only really thing from 12.1 that you need is finding the center and the radius of a circle, if you're given the endpoints of the diameter. And then 12.2, finding the equation of a circle, graphing it based on that. And then 12.3 was the ellipsis stuff that we just reviewed. So finding the equation, given information, and graphing it, given the equation. So the piecewise functions are the ones that look like this. So the f of x is true for different values in different ways. So for this one, f of x equals 2 if x is less than or equal to, oh, that should be greater than. X is less than or equal to 1. Or 3x plus 1 if it's greater than 1. So you can have an overlap there because it would fail the vertical line test. It can't be the same dot. So the first thing we're going to do is graph this. So if I said that y equals 2 for those first values, what kind of graph is a y equals 2? It's a line, and specifically a horizontal line, right? The values of y never change. So we're saying this is true for the values that start at positive 1 and are less than or equal to it. So remember, a solid dot is the or equals. An open dot is a not or equals. So if that said less than or greater than, it gets an open dot. If it says equal to, less than or equal to, or greater than or equal to, it gets a solid dot. And then the second part of that graph is that y equals 3x plus 1 for the values that are greater than or greater than 1. So I have two choices here. Plot points starting at 1 and getting bigger than 1. So 1, 2, 3. Plug them in. So 3x times 1, or 3 times 1 plus 1 would be 4. 3 times 2 plus 1 would be 7. 3 times 3 plus 1 would be 10. And then I can plot those 3 points. So 1, 4 would be an open dot because it can't include it. 2, 7, 3, 10. And it's a line, so it's going to keep going on that direction. The other thing you can do is just graph your line and erase the part of the graph that you don't want to use. So if it's y equals mx plus b, I could have started at 1, gone up 1, 2, 3 over 1, 1, 2, 3 over 1, drawn that line, and then erased from it what you don't want to use, which would have left us with exactly what we had drawn the first time. Again, this is an open dot because it doesn't include it, and it would continue on in that direction. Questions on that one? So you are going to have to graph piecewise functions, okay? They're not bad, but you do have to graph them. Ian?
Can you go over, like, if you have, like, an open that close down the same point?
So if it overlapped, let's say that this was, instead of this being 2, this was 4. This would have been a solid dot, and I would have gone straight through. The solid dot being on the same spot as the open dot overtakes the open dot and makes it a solid dot.
Yeah, so if there's an open and a closed, it's closed.
Exactly. Okay, and then you have to evaluate the piecewise function. So if it said f of negative 3, using this same function, I figure out which range that falls in. So is negative 3 less than or equal to 1 or greater than 1? It's less than or equal to 1, which means f of negative 3 is what?
2.
Good. How about f of 1? Is 1 less than or equal to 1, or is it greater than 1? It's less than or equal to, right? Which means this one is also 2. And then f of 3, good. It's bigger than 1, so this is the 3 times 3 plus 1, or 9 plus 1, which is 10. Questions on any of that?
The fixed line.
Yep.
Like your point, why isn't it 1, 2 instead of 0, 2?
Oh, because it's from where x is less than or equal to 1. So you have to go all the way over to where x is 1.
When it's a quadratic, how do you graph it?
Plot points. So if it was quadratic starting at x is greater than 1, I'd plug in 1, I'd plug in 2, I'd plug in 3, plot my points, and make it the parabola.
How do you know when to do the parabola?
How do you know when to do it?
Yeah.
The points should give you that curve.
Oh,
Yeah. You'll know it from the equation if it's squared, right?
Mm-hmm.
Okay, 6.5 was all the things you can do with functions. So we learned how to add functions, subtract functions, multiply them, do the composite. We also learned dividing, which is not on your test, so let's narrow it down to just these. Okay, so adding, subtracting, multiplying, and then composite functions on the bottom. So if it said find f plus g of x, and it gives you f of x and g of x, all you gotta do is add them and combine your like terms. So this would be 3x squared plus 2x minus 1 plus 4x plus 2, and then combine your like terms. So I'd get 3x squared, positive 2x and positive 4x, positive 6x, negative 1 and positive 2, positive 1. The next one says f minus g. Pay attention to the order. So it says the f goes first, which means I change the signs on everything in g. So the f stays exactly how it is. And then it's minus both terms in g, which is a mistake a lot of you made on the quiz. That minus has to go to both. So this is a negative 4x and a negative 2. This is 3x squared minus 2x minus 3. Then comes the multiplication. 3x squared plus 2x minus 1 times 4x plus 2. And then you would FOIL this out. So I distribute, 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 distribute. So the first one would be 3x squared times 4x, or 12x to the third. 3x squared times 2, 6x squared. Go to the 2x. 2x times 4x is 8x squared. 2x times 2 is 4x. And then the last one, negative 1 times 4x, negative 4x, negative 1 times positive 2, negative 2. Combine your like terms. So this is the only x cubed. There's 2x squared. Add those. There's 2 x's. They'd actually cancel each other out. Minus 2. And then the next one is f of g of 2. So these are your composite functions. And you want to work innermost parentheses out. So the first thing I'm going to do is find g of 2. So I go back to where g is. And plug in 2. So g is 4x plus 2. 4 times 2 plus 2. 8 plus 2, which is 10. And then I want to find f of 10. Go back to the f, which is 3x squared. So 3 times 10 squared plus 2 times 10 minus 1. 3 times 100 plus 20 minus 1, 300 plus 20 minus 1. 320 minus 1, which is 319. And that second overall answer is your answer, not in two parts, just that last one. So we're going to do the same thing for g of f of negative 1. Start innermost parentheses. This time the f comes first. So 3 times negative 1 squared plus 2 times negative 1 minus 1 is 3 times 1 minus 2 minus 1. 3 minus 2 minus 1, 1 minus 1, which is 0. And then I want to find g of 0. So 4 times 0 plus 2, 0 plus 2, which is 2. And then again, that last answer is your overall answer. All right, so that's the start of the review. All right, so 6 with inverse functions. And we learned how to use the horizontal line test to determine if this function's inverse is also a function. So you'll look at the graph that they give you. It'll say use the horizontal line test to determine if the inverse of this function is a function. Okay? If it passes the horizontal line test, if it is a function, its inverse is a function, and if it doesn't, then it's not. So if I were to draw vertical lines through that first example, are one of those horizontal lines, are one of those lines gonna hit this graph at more than one point? Yeah, so this function, while this one's a function, the inverse is not a function. Yep. So we've done these review notes for the quiz.
Right?
Yep.
Okay.
They're probably different examples, but they're probably pretty close because my brain only goes so far with examples. How about the second one? If I draw horizontal lines through this one, does it hit at more than one point? It doesn't, right? None of those horizontal lines hit at more than one point. So this one, the inverse is a function. So this should be an easy question. It should be an easy gimme question because it's either a yes or a no, and the instructions say what kind of line to use. Okay, it says use the horizontal line test to determine if the inverse is a function. The review. All right, so then determine if the function's an inverse using composites. So if you are looking at f of x and g of x, and you do f of g of x and it equals x, and g of f of x and it equals x, then they are inverses of each other. So the question is simply, are these two inverses of each other using composition functions? So the first thing I'm going to do is find f of g of x. So I'm going to take the g, and I'm going to plug it into the f of x. So x minus 6 plus 6. These cancel, and I get just x. And then I have to do the same thing the other way around, g of f of x. So I take the f, and I plug it into the g, x plus 6 minus 6, and these cancel, and I get x. If both of these are x's, then these are functions. If they are not both x's, then they are not, then they're inverses. If they are not both x's, then they are not inverses. This is my last request with you, and then I'm writing you off. Okay, then we got into 12. So all that stuff was on your quiz, and then all this stuff is the stuff since your quiz. Okay, these are all your conics. The only thing from 12.1 is this. Find the center and the radius of a circle with a diameter that has the given endpoints. So if you could picture a circle with a diameter with given endpoints, how would I find the radius, let's start with the center. How do I find the center of this circle? Midpoint, good. So the radius, do it again. Center equals midpoint, which is x1 plus x2 over 2, y1 plus y2 over 2. All right, so if I want to find the center of the circle with these endpoints, I would find the midpoint, so -1 plus 2 over 2, and then 7 plus a -4 over 2, which is 1/2 and 3/2. This would be the center of the diameter, or the center of that circle. And then the next thing it asks for is the radius. So each of these little segments would be a radius, right? So the radius is the distance from the center to the side or the center to one of those endpoints. There's two ways to find the radius based on the information that they give you. What's one way? Good. So I can use the distance formula with my original endpoints and divide by 2, because the original endpoints are going to give you the entire diameter divided by 2, and I get the radius. Okay. The other option is what? How else can I show the radius? The distance between the center and what? And one of the endpoints. So I can either pick to do the whole diameter, divide it by 2, or I can pick either one of these in combination with the center and not divide by 2. If the center's got a fraction, I would avoid the second option. I would stick with the first one. You don't want to deal with fractions inside squares and all that stuff, okay? But if it doesn't, then it's actually one less step because you don't have to divide by 2. So for either of those, you have to know the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. So because there's fractions in my center, I'm going to find the whole diameter. And then I'm going to divide it by 2. So I'm going to use these points underneath. x2 is 2 minus a negative 1 squared plus y2 is negative 4 minus 7 squared. 2 minus a negative 2 becomes 2 minus a negative 1 becomes 2 plus 1, which is 3. Negative 4 minus 7 is negative 11. This is 9 plus 121, which is the square root of 130. Yep.
I have two questions. The first one is, what's given to you, like that red part, is that the end one?
Yes, the end points of the diameter will be given to you.
Okay, and then how do you know which one is like x1 and x2?
It doesn't matter.
At all?
As long as within one pairing I make them both 1s and both 2s, it doesn't matter which one you make x1 or x2.
So for the distance formula, like...
I could have switched that. I could have done negative 1 minus 2 squared plus 7 minus a negative 4 squared, right? Still negative 3 squared plus, because you square it.
Negative would be squared up.
Exactly. So, but that's the diameter. I would divide it by 2 to get the radius. So if it's a perfect square, then obviously you want to reduce it. If it's a radical, you can break apart. Then you want to simplify it. In this case, 130 would be 2 and 65, which is 5 and 13. None of those repeat. So you can leave it as the square root of 30 over 2. So again, to get the center, you would use the midpoint of the 2 points given for the endpoints of the diameter. And then for the length of the radius, you can either find the length of the diameter using the distance formula and divide by 2, or find the distance from the center to one of the endpoints. Questions on either of those? That's it from 12.1 you need to know, because the rest was all based on the calculator, if you remember. Okay, 12.2 was circles. So you're either going to be given the center and the radius and asked to find the equation, or given the center and a point and asked to find the equation. Standard equation for a circle is x minus h squared plus y minus k squared equals the radius squared. So for the first one, it goes right in, right? Remember, you always change the sign, because if it was, this is my h, this is my k, and this is my r, it would be x minus 4 squared plus y minus a negative 3 squared equals 5 squared. So this is x minus 4 squared plus y plus 3 squared equals 25.
So is the x of the center always going to be 8? And
Yes.
the y is going to be 8?
Yes. Yep. Same for, think about it, it's the same for the hyperbola, for the ellipses too. The x center is always h, the y center is always k. That won't change. So Lauren's kind of like piggyback on your question before. The good thing is that this is multiple choice. So hopefully you recognize the standardized, the standard form of an equation. Just be careful, because probably the same answer will be there, but it will say x plus 4 squared plus y minus 3 squared equals 25, so that it's close but not right. Or it would say x minus 4 squared minus y plus 3 squared equals 25. Or maybe the radius isn't squared. It's all going to be some sort of combination of these numbers. You just got to be careful with your signs. Jen? No, the whole thing is multiple choice. The whole thing.
How many questions are there?
20.
No graph in mind.
So even the graphs are multiple choice.
So it'll say like.
Identify which of the graphs.
Oh,
All right, so center and containing a point 1, 2. So again, like if you want to get a visual on this, center being at negative 2, 5, negative 2, 1, 2, 3, 4, 5. This is the center of my circle containing the point 1, 2. That means my circle goes something like that. I still need the same pieces of information. So I still need the center because I need HK. And I still need the radius. So given to you is the HK, right? This is my H and this is my K. What's missing?
R.
How do I find it? From what to what? Good. So there's only 1 point this time. It gives it to you for it. So the distance formula from the center to the point. And it doesn't matter which ones I make, X1s, Y1s, as long as I'm consistent. So 1 minus a negative 2 becomes plus 2. Plus 2 minus 5 is 3 squared plus negative 3 squared. Square root of 9 plus 9, square root of 18. So I could take the time to work that out and get that it's 3 root 2, but what do I do when I plug it back into the equation? What do you do with the radius? You square it anyways, so I don't even need to keep going. If it asked me for the radius, then I would make it 3 root 2 because that's simplified. But if I'm plugging it back into the equation, so this becomes x plus 2 squared plus y minus k squared, which is 5, equals the square root of 18 squared, which is 18. God bless you. Questions on circles. So hopefully circles is not bad. Yeah.
Okay, so for the distance formula, you took the center and the contained point.
Correct.
Okay.
Because the distance from the center to that point would be the radius, right? Which is where we were yesterday, right? So the standard form for ellipses come in 2 ways. One if it's horizontal, one if it's vertical. So if it's horizontal, where's the A go? Yep. Good. So this would be x squared over a squared plus y squared over b squared. Remember, a is always bigger. So a is the biggest. And it goes under the x squared if it's horizontal. It goes under the y squared if it's vertical. Okay, so the A comes from the vertex, the B comes from the covertex, and the C comes from the foci. So when you're provided information, that's where it's going to come from. A is the number other than 1 that you get from the vertex. The B is the number, other than 0. The B is the number other than 0 that you get from the covertex, and the C would be from the foci. Again, the number other than 0. So if you got that the vertex was 0, 5, the covertex was 2, 0, and the foci is 0, 3, then this is my A, and it's not going to make sense. I actually should make numbers that make sense. This would be 4. So this would be A. This would be B, and this would be C. You're going to get given 2 of those 3. The easy ones are if you get the A and the B, then you plug it right into the equation. If you get given the A and the C, then you've got to use C squared equals A squared minus B squared to get the B. And if you get given the B and the A and the C, no, the B and the C, then you use C squared minus equals A squared minus B squared to get the A.
What's the post? Like I was trying to watch.
So if you draw this ellipse, 0, 5 is 1, 2, 3, 4, 5. There's a vertex there. There's also one in the opposite direction, same distance from 0, 0. So this is assuming that my center's at 0, 0, which is what you'll be finding the equation of if you're finding the equation of a ellipse, it's going to be with a center at 0, 0. You could get asked to graph one just like we did the other day. Graph one when the center's moved, but I'll get to that in a second. Then the co-vertex is on the other axis. So 1, 2, 3, 4, it would be here, and 1, 2, 3, 4, it would be here. The foci is along the axis where the vertex is. The major axis, right? So this would be on 4. So the foci would be here.
Wait, so the foci is the endpoint to the major axis?
No, the vertex the vertices are the endpoints.
Okay, so what's the foci?
It's so the relationship is like a right triangle. So you're going to get given 2 of those 3. The foci is the distance from 0 to C.
Okay.
You'll be given either A or B or C and have to find the other one. So if you're given A and B, you're done. You can find the equation. But they can sometimes give you the foci, and you have to use the foci to get the A or the B. Does that make sense? If I give you A, B, you can go directly to your equation, because that's all you need. You need to know what kind of ellipse it is it vertical or horizontal, and you need to know A or B, A and B. But sometimes you're not given A and B, sometimes you're given A and C, or B and C. So you're using the foci to find the other missing part. Does that make sense?
Yeah.
Okay. Ian, you had a question?
Yes.
Yeah.
What about for the circles? What about the ones that like aren't on the origin?
So the only thing you'll do with those is graph like we did on the homework check yesterday, which I'll get to in a second. We didn't find the equation. You can, but we didn't find the equations.
Okay.
We didn't find equations when the center wasn't at 0, 0.
But for ellipses we did.
No, we didn't find equations. We graphed them.
But like, then what was the thing that it was like y minus whatever?
So that they gave you the equation, you had to graph it.
Oh, so that's it, just plugging in numbers for that.
Or that's just plotting your points.
Oh.
Yeah, you won't have to do the other way around. Where if I said the vertex is this, the foci is this, you have to give me the equation. That you won't have to do. If the center's not at 0, 0. All right, so go bottom first. Let's do that because that's where we're kind of at right now. So if I gave you this information, could you give me the actual, or the equation?
Yes.
So the first thing you want to do is figure out if it's vertical or if it's horizontal. Because that'll determine if the A goes under the X or the Y, right? So if it's at 4, 0, it's horizontal, right? Because 1, 4, 0 means that the vertex is here, which is wider than it's tall. No, the vertex is always the greater. It depends on if the number's in the X position or in the Y position. Does that make sense? So if the number's on the X, then that's the part that's the longest. If the number's on the Y for the vertex, then it's vertical. So I know this is horizontal, and what that tells me is that the A squared comes under the X squared. And I'll tell you right there with multiple choice, you can already eliminate options. Anything that's got a bigger number under the Y, I know won't work. So if you're running out of time and you have no idea how to find the equation, you can at least use some process of elimination to help you narrow it down. So if I get given the vertex is 4, that means A is 4. And the co-vertex is B, that means 2 is B.
That's the midpoint.
No,
Or,
that's the standard form of a ellipse. Mm-hmm.
so for the, I still don't get the foci.
So I don't need it yet. For the first one, you don't even need it.
Right.
Because I could just plug it in. So this is 4 squared. This is 2 squared. So this is x squared over 16 plus y squared over 4 equals 1. That's it. I'm done with that one. So if it gives you A and B, you're done. You just got to figure out is it horizontal or vertical to figure out where the A goes. If you're given like the second one, so now I'm given the vertex, which is my A, and I'm given the focus, which is my C. I have to find the B. So C squared equals A squared minus B squared. So 2 squared equals 4 squared minus B squared, 4, negative 12. And again, just like that last one, I'm not asking you for b, you don't have to simplify that. I'm going to eventually square it anyways. So keep it square root 12. Now I got to figure out, is this vertical or horizontal? So if my vertex is at 0, 4, it means I'd have the other vertex at 0, negative 4. Is this vertical or horizontal? It's vertical because the vertex is on the x-axis, which means that now the a squared is over the y. So x squared goes over b squared, which in this case is square root of 12 squared. The y goes over the a squared, which is 4 squared. So x squared is over 12. Y squared is over 16. And again, as soon as you find that it's vertical, you could probably go through your answer choices and cross out anything that has the bigger number under the x. Questions on those? Okay, and then the last part is graphing. So what's the difference with these two? God bless you. One's vertical, one's horizontal. How do you know which one's which? Bigger numbers on the bottom of the y makes it what? Vertical. Bigger numbers on the bottom of the x makes it horizontal. Both of these have a center at 0, 0, because there's nothing added or subtracted from x or y. The a squared is always the bigger of them. So the a squared here is 25, which means a is 5. The b squared is 4, which means b is 2. And it's vertical, which means I use the a on the y-axis and the b on the x-axis. Again, use process of elimination. As soon as you see that equation and you see that the larger number's under the y, you know you should be looking for a vertical ellipse, and you can cross out any of the horizontal ones.
Is it easier to remember, like you remember how I was talking to you about the placement of the x squared under the a?
Yeah.
Is it easier to remember it by like which, like if it's vertical, the a is under the y squared, or is it easier to remember it like if the bigger number's under it, that's it?
Whichever the bigger number is under is the major axis. That letter's the major axis.
Okay.
So if you need it doesn't, whichever makes sense to you.
That's what I was asking.
Yeah. Like if you see the bigger number under the x, then it's the x-axis, which is major, which makes it horizontal. If the bigger number's under the y, then the y-axis is the one that's major, which makes it vertical. And it seems silly, but people still even will look at it and switch the x and y axes. So just be really careful. All right, so if b we've already determined is horizontal because the bigger number's under the x-axis, right, which would make it horizontal. The a squared is still the bigger of the two, which is 25, making a 5. The b squared is the smaller of the two, is 4, making b 2. And then it's horizontal, which means I'm going to the right 5, left 5, up 2, down 2. Questions? I'm just going to add one more if the center shifts, and then we're done. Everybody's good on if the center is at 0, 0. Yeah? Okay. So now, to refresh, if the center gets shifted, So is this horizontal or vertical?
Is
It's horizontal. This time my center is not at 0, 0. This time my center is at 4, negative 2. Good. The a squared is still the bigger of them, which is 16, making a 4. The b squared is still the smaller, which is 4, making b 2. So then I, on the graph, start at the center, 4, 1, 2, 3, 4, negative 2. So from this point, it's horizontal, which means I'm using the A to go right and left. From the A, I'm going 1, 2, 3, 4 to the right. 1, 2, 3, 4 to the left. And then I'm going up 2 and down 2. A very lopsided ellipse, but you get the point. Questions on any of the review? So 6-3, 6-5, 6-6, 12-1, 12-2, 12-3. We good? Okay, so you